Great, thanks all. In this video, I will introduce you to integration analysis using EViews software. This is EViews version 12. The first thing that we need to do is to upload file or data into the software. So what we need to do is to click on file menu, then open. The data that I'm going to use for this example is stata data set. Therefore, that is foreign data. That is not in EViews data format, since I'm going to import it from other data or other software's data format. I need to choose or select this foreign data as work file. When we say foreign data in terms of EViews language, it is to mean importing data formats other than the data format in EViews. For example, from Stata, from Excel, from SPSS. So the data that I am going to import is stata data format. So I need to select foreign data as work file. And I need to locate the place where my data is stored. I put it on the desktop exactly data 2021. This is the stata data format. I need to click on OK, finish, and then no. As you can see, the data is imported into EViews software. And using this data, I am going to show you how to deal with cointegration analysis. And always don't forget to select the dependent variable first. And in my case, the dependent variable is price of coffee traded at Ethiopian commodity exchange, ECX, and the rest are independent variables. So once the first variable is selected, then hold on Control key, look, select the first one, the dependent variable, and hold on Control, then select others. All these are independent variables that I have. Then once the variables are selected, right click on it and then open, then as equation, open as equation. Why? Because ARDL is a single equation cointegration testing approach. Therefore, once the variables are selected, have right click on them, then open the variable, the selected variables as equation. These are the variables which are going to be included in the model. And here we are going to select estimation settings. Since we want to apply the ARDL approach, we click on it, and then we get ARDL autoregressive distributed lag models here. And once this is selected, we have fixed regressors specification here, restricted constant, it says. And let's start with this one. And the maximum lag allowed for dependent variable is 4. For dependent variable is also 4. You can change this one normally. You can change. And you can change the model selection criteria. Here, the selected criteria is Akaki information criteria. You can make this one Schwarz-Bayesian if you want, for example. And now let's select. I mean, let's click on OK. Look, here is the estimated result. Here is the selected model. For the dependent variable, we have lag 1, and this for the last variable, we have again lag 1. And having this, we need to know whether there is a long-run co-movement or co-integration or not. And in order to do so, you need to click on View, then Coefficient Diagnostics, and under Coefficient Diagnostics, you can select long-run and the bounds test. And here is it. Well, this is a long-run coefficient. Look, long-run coefficient. And here we have the bounds test approach. This is the test statistic, and we have critical values here. And we said that if this estimated test statistic is greater than the upper bound critical values at a selected level of significance, it implies that the variables are co-integrated. Accordingly, 6.28 is greater than 3.2 when 5% level of significance is considered, 3.9 when 1% level of significance is considered. And it implies that there is co-integration, long-run co-movement between the variables. If that is the case, you can go back to consider the long-run coefficients estimated. For example, this one is statistically significant. The same is true for this. This is also significant. And the only insignificant variables are money supply, trade openness, and the volume of export. Now, we are left with short-run estimators, which we call error correction 4. This is the error correction model, the short-run parameters. And this is the error correction model, error correction term lagged by 1 time period. It is minus, I mean its sign is negative. It's between in absolute term between 0 and 1, and it is statistically significant. And this is another confirmation which implies that the variables are co-integrated, or the variables are co-integrated in the long run. They have a co-integration. There is a co-integration, there is a long run co-movement. Once we're done with this, we need to test whether the estimated parameters are stable or not. And in order to do so, click on View and then select Stability, Diagnostics, and then select Recursive Estimates. And from here, we have Cointegration Test and the Cointegration Squares Test. And let's start with Cointegration Test first. And here is it. This dotted line in red shows 5% critical lines, and if this Cointegration line runs out of the critical values, it implies that the estimated parameters are not stable. But since we have a line within the critical values at 5% level, it implies that the estimated model is stable. And now let's try out using Cointegration Square. And in this case, we select Cointegration Squares Test and click on OK. Again, the line is between, or the line is within the 5% critical lines, which confirms that the parameters or the estimated model is stable. As this is all about using EViews for cointegration tests.